Guys, in this video I wanted to take some time to build upon a previous video that I did talking about state text and command hierarchies. What we're going to do here is actually create a basic PID loop control, a PID loop output control. This is typically how I would not do this type of activity, but this is something I think is a good exercise to help give you a better understanding of some of the basic functions within CCT, as well as how some of these points connect to each other. Now, what we're going to begin with is starting the system. And what we want to do there is we are going to want on our system a way to turn it on and off from the front end. So inside the network inputs section of CCT is where we are going to create a couple of things. The first thing that we're going to create is a couple of Boolean inputs, or I should say enumerated inputs. These are what we're going to use to turn our systems on and off. In fact, we're going to go ahead and use a Boolean as well. I'm going to select one of those and I'm going to call it system enable. I'm going to select an enumerated and I'm going to call it heat and cool. Now I've got my inputs here. Something that I'm going to need is also a hardware input. This is going to be a zone temp sensor. So I'm going to select my plus sign. This is a physical input. So zone temperature. Now you can use a nickel sensor, you can actually use a network sensor, it really depends. For the purposes of what we're doing here, we will simply grab a 1K RTD. Call it zone temp, we will leave that name just as it is. We're going to hit finish. Now we have our zone temperature as well as our system enable and our heating and cooling command. We're also going to need a couple of outputs. We need to have our physical output for the heating and cooling valves. So I'm going to hit my plus sign. And what I want here cooling, and let's just do a 0 to 10. Going to leave the name the same. Hit finish. I'm also going to grab a heating. Leave it a 0 to 10. Hit finish. I now have my two valves. We've got to control those valves based upon what we have here. What we're going to create is, for the purposes of this video, we're going to create a hybrid activity. I'm going to want two of these. I want one for heating and one for cooling. I'm going to double click on one of these and I'm going to change the name of it. There's our heating. Here's our cooling. Now, we have our hybrid activities. Let's begin with the heating. I'm going to go to View Logic. And what we see inside our hybrid activity is the actual state options. Okay, the highlighted in blue, that's what we're working in. If I was working for the section of this for it to be off, I would highlight that individual section. You can see here I clicked on the off, and then of course when I go on, it's the same thing. Whatever is highlighted is the section within this block that I'm working in. The way you'll start out is by controlling the state itself. Okay? So there's a few things that we need to pull in. We need to control this state with our inputs. So I'm going to select Boolean input, and I'm going to select an enumerated input. Our Boolean input, if you will remember, is the one that we were going to use for the system enable. So we'll just call it system enable. Hit apply, hit close. The enumerated input is the one that we called for heating and cooling. So we're going to change that label. And I'm going to hit apply. But for review, I'll pay attention to the state texts. We need to remember that. I'm going to hit apply, and I'm going to hit close. I'm going to bring up my connections panel. Here's my system enable, and here's my heating and cooling. I'm going to make a connection. Okay, I want to make a connection to those inputs that we created, those network inputs. So I'm going to right click on my system enable, make connection. And you can see here from my network inputs panel, I have the option of tying it to that system enable. So I select that and hit OK. And now my system enable is connected to this logic block. My heating and cooling, something that we need to look at. For the heating and cooling, the state texts for this, let's double click in here. We know that this one is true and false. The state text for our heat cool is currently off on. Our logic, when I look at it, when I go into my details, it is also off and on. But what happens if I wanted a time of freeze protection where this would go to a maximum heating? If I'm trying to protect a coil or something like that, I would want that to go to maximum. So what we're going to do, I'm going to hit my edit button. And instead of this just being an off on, I want this to be off, on, and max. So I'm going to select this, my little arrow. We have off, on, control, off, on, hold, and then here off, on, max. And that's what I'm going to select. And I'm going to press OK. And I'm going to hit apply, and I'm going to hit close. Now, here's my heating and cooling. I'm going to right click on it, make connection, and I get this screen here. No blocks with matching criteria found. And the reason for that is our state text of our inputs. So now I'm going to come over to my heating and cooling. I'm going to view the details of it and press the edit button for the state text. I'm going to change this to match what I needed before, the on, the off, and the max. Press OK. And just for clarification, let's go ahead and add the max. Or I could call it freeze protection or just whatever else I'm wanting to do with it. Hit apply. Hit close. Now, highlighting back my heating section. Here's my heating, cooling. Right click, make connection. And now I have the option to connect to that network input. Press OK. Now my connection is made. But we're not done. I'm going to view my logic. Expand this up. We see here I have just my states of off, on. I don't have that max in here. So what I'm going to do is right click, view details. You can see here the state is off, on. I want to change that to off, on, max. What it's going to do now is it is going to add a block for us. So when I close this out, you can see now we have off, on, and max. Some of the other things that I need to do. I need to grab that zone temperature. So I'm going to grab a floating input. This is something that's going to be used in our logic, and I'm going to drag it onto my panel. Double click into it. This is an analog input, and we're going to call it zone temp. I'm going to hit apply, close. Now, I still need to make my connection to my physical input. As you can see here, when I created that in my logic, it created it here on the screen for me. So now I can make the connection. I can right click, make connection. There's my zone temp under hardware inputs, because that's what it is here on the panel. Hit OK, and now I have made my connection to my input. Physical hardware input is now connected into my logic block. I need to do the same for my outputs. I'm going to lower this down just a bit, keep it to where you can still see it. Let's grab it a little differently. I'm going to come over here to activity outputs. And I'm going to grab output floating, because there again, this is going to an analog output. Drag it over. And I'm going to call this heating output. Hit apply, close, and now you see my heating output. I'm going to right click it, make connection, tie it to my physical heating output. Hit OK. Now my logic block is connected to a physical hardware output. We still need to control our state. So what we're going to do, I need a command hierarchy. Let's pull this over just a bit. Command hierarchy enumerated output. I'm going to grab it, drag it out here. Give myself just a little bit more room to work with. from my command hierarchy, I'm going to double click into it. And we'd mentioned the state text before. My outputs, I'm going to hit edit. And this I need to change to match my inputs of off, on, and max. My output for this command hierarchy also needs to match that. Off, on, and max. Inside here, there's some combination of things that I need to add. I'm going to insert a row. But let's look at something. Let's go back to our screen. I've got two inputs. One output. My output here, I'm going to link to the state block. Okay? Through this command hierarchy, I'm going to be able to select the state that I want this logic to be in. Okay? My system enable. If I try to make a connection here, you can see that I have one section that is green. So I'm going to make my connection. Heating, cooling. I'm going to highlight that. And again, make my connection here. But it's not letting me. Let's go back into our command hierarchy and see why. Again, it is our state text. So I hit edit. Here is our system enable, true and false. It's our Boolean input, so it's what we need it to be. Our enumerated is not. You can see here we only have off and on. Okay? Now when I look back at my input, my state text for my heating and cooling, off, on, max. So it clearly does not match. So I go back into my command hierarchy, hit edit, and right here, drop this down, and select on, my off, on, and max to make it match. Hit OK. Hit apply, but we're going to be coming back to this. Now I'm going to make my connection. Now, since we're working with heating, I want these inputs to be in a particular state in order to turn it on. For example, my input 1 is off. If that input 1, I don't care if that input is on, but if my system enable is false. So what I'm going to do, I'm going to go in here and click edit. This is my two inputs. This is my output for this block. So if at any time that this system enable, this input number 2, is false, I want that output to be off. If the system enable is true, I'm only going to want my input to be on as well. The only time that I want this to run is when the system is on and my system enable is true. I've got room here for some additional logic. If my system enable is true and my input is off, again, I do not want that running. But I still have additional room. And this is something that you can put in just to make sure that you have everything covered. I'm going to right click, insert row. If my system enable is true, my system input is max, then I want my output to be max. For example, if this was for freeze protection. But what happens if I don't have my system enable as true? I still want that freeze protection. So if I select this to max, I'm going to select this regardless of whether or not it is true or false. And guys, in practice, your freeze protection should be up high on the priority. So we can actually move that up just like this. Okay? Even if this is false, if my system enable is false, if that hits max, then I want it to turn on and protect that system. I want that heating to go full blast for freeze protection. But there again, guys, this is just an example. Now that I have these blocks, I'm going to hit apply. And I'm going to select close. We can see that we can now control our block. So what are we going to do with this block? Well, in this section here, you can see when I click this, all of that other logic went away because, again, I'm only working with what is highlighted. So in this section here is what I'm working with. But what do we want to do if we turn this system off? This is our heating output. If I'm off, I don't want that valve to open. So what I'm going to do is add a constant. So over in my logic, I've got all these different options here that I can use. But what I want is a floating constant value. Whatever the constant value is set up for in here, that's what it's going to be putting to the output. You can see here my default value is 0. I'm going to connect this to that hardware output. Whenever this logic block is in off state, then it's going to put an output of 0 to that heating output. Now when I select max, you notice that went away because, again, we're working in what we have highlighted. Whatever happens in the state, what we have highlighted here is what we're working with. Again, I want to grab that constant floating because this is freeze protection. And if I went to max, you know, if I had a safety to trip or whatever, I want that value to go to 100%. So I enter 100, hit apply, hit close, and now I'm going to make my connection. Now if I click back up here to state, if it is determined that I need to go to max, that the heating cooling for whatever reason is tripped, whether it be by network input, or I could have additional logic in here to where it is a physical hardware input. If it switches it to max, then it's going to drive that valve 100% open for freeze protection. But guys, this is just an exercise to help you better understand how some of this works together. When we are off, everything is normal. I want that valve closed. But if we have a situation to where we have freeze protection, or if we know it's going to get super cold, we can open that valve. But what do we do when we want it, when we're in the on position? What do we do with that? That's where we have our PID loops. There's two items here, the PID preprocessor and the PID loop itself. We're going to begin with the PID preprocessor, and then also grab the PID loop and drag it out here as well. Now let's put these close, and I'm going to zoom in. Connecting these is pretty much just straight across. Okay? If you can read the text on your screen, minimum tuning, just straight across. Because we've not exposed any points or anything like that. We're going to look a little deeper into these in just a moment. But right now, just for an example, I want to get you started. Let's dive into this PID preprocessor and look at a few things. The process ID is what you need to pay close attention to. For this particular PID loop, we're going to be setting this up for zone temperature, for zone temp control. If I hit edit, I'm going to show you something, because there's a lot you can do with this PID preprocessor. I can use it for zone humidity, I can use it for heat exchangers, airflow. There's just everything that you can do right here within these. Condenser water supply temp, all that, discharge air temp control. What you select in here is going to affect how this PID preprocessor, as well as how your PID loop itself, will work. I'm going to hit cancel because I don't want to do anything to this, and I'm going to hit close. When I double click into the PID loop itself, those values from that PID preprocessor are going to pre-configure a lot of what we have here for our control. We're not going to get too deep into all of that now in this video, but that's just something that I want to make you aware of. We can also select manual tuning or automatic tuning. Okay, I'm going to close this out. Our process variable. Do you remember that zone temperature? I grab that zone temperature and I'm going to link it here. That's my process variable. That's what I'm wanting to control. But we have a problem. I don't have a set point. So I'm going to add one. I'm going to grab another input, drag it out here, double click in here, call it zone set point. Hit apply and close. Now I have my set point. How am I going to write to that set point? I'll go back to my control screen. I need another network input. If I'm doing it from the front end, I would add it here. If I have some type of a physical input, a physical potentiometer or something like that, warmer, cooler, I could add that depending on how it's communicating. I would add it under the hardware. But since this one is a software input, a set point for our software, we're going to put that here, and I'm going to call it zone set point. Hit finish. Make my connection. Right click. Make connection. Network inputs, zone set point. Hit OK. Now I'm connected. Let's go back into our logic. I have my heating output. I have my present value, my saturation state. There's a lot of things in these PID loops that you can pull out of them. The only thing that I need now is to take the present value to my heating output. And now my PID loop is connected to the physical output. There's something I want you to pay attention to inside a PID loop. Let's look at the input section of this PID loop. And there's something very important for you to pay attention to. Right here where it says direct acting, it's either true or false. Depending on how you select this will affect how your PID loop performs. If this is something that you need to drive an output positive, this is going to play into that. If you need to drive it negative, it's going to play into that. Okay? For example, if my zone temperature for this is cold, I want it to drive that valve open. At the same time, if it's cold and I'm looking at a cooling valve, I would want it to drive a cooling valve closed. That can be done right here with a direct acting or reverse acting. Depending on how you're using your PID loop, that's something that you need to remember. I have been into systems doing troubleshooting and things like that. Everything looked fine, but when you dig into the PID loop, this would be the opposite. And that's just a little bit of an informational thing for you. We're going to leave that true for now. And I'm going to hit close. Now, let's go back up to our state. Now, what we have is our basic logic, heating, cooling, through our command hierarchy, controlling the state of this activity. If we're turned off, we're going to write a value of 0 to the heating valve. If we are turned on, then the zone temp is going to control based through the PID loop, comparing the set point to the actual zone temperature. And then in max, if we need a freeze protection, we're going to write a value of 100 to that output. That's the basic principles of using the inputs, the hybrid activity, and the state text and the command hierarchy within Johnson Controls CCT. if I were to write logic for the cooling output, it would be pretty much the very same thing. Let's bring our connections back up, and you can see currently I don't have anything there. I would need to go in here, go into details, follow the process through again. The difference is, in my logic, in my command hierarchy, the way that I put it on my block here, I would need to change this slightly. What I would need to change, if I did not want that valve open for water flow or whatever when it went to max, I could put that, change my logic a little bit to where it would basically, if the system was in max for any reason, and if I had my system command to false, then it would not do anything. It would not necessarily drive that valve open. However, if my system was enabled and I went to max, then it would drive it fully open. But there again, guys, this is just an example. The purpose of this is just to get you thinking about how some of these things interrelate together. This system is very complex in its capabilities, but you need to be able to break the most complex elements down to the basic principles, and that's the purpose of this video. But guys, I hope that this is something that helps you in learning CCT. If you have any questions, leave those down below. Again, guys, this is not necessarily a full system or anything. I'm just basically wanted to put some fundamental principles out there for you to understand. But guys, thanks for watching. Check out the rest of the videos on the channel. Be sure to subscribe. Check out all of the links down below this video. Visit my website at systemcontroltech.net, and we'll see you next time.